Here we're going to look at another number pairs and sequences problem. So here we're given a sequence A of n defined as follows. So A of n, or in other words the nth term, is, so first we have 2n sixes, and then we have n plus 1 fives, and then we have n plus 2 sixes, and then we have n plus 3 fives. And this works for all natural numbers n. So we need to write down the first four terms of A of n, and then for part B and part C we're given two more functions. First one is d of n, which will be the number of digits in term n, and then s of n, which will be the sum of digits in term n. And for part D, for what values of n is the number of sixes in the nth term is equal to the number of fives in the same term. For part A, I've written all the answers. I'm just going to explain what is going right here. So according to our formula for A of n, A of 1 has two sixes on the front, which is just 2 times 1 according to the formula. And we have 2 fives, 3 sixes, and 4 fives. For A2, this pretty similar. We have 4 sixes, 3 fives, 4 sixes, and then 5 fives. Again, according to the formula right here, you can just check that on your own. And then so on for A of 2 and A of 4. And then for part B, we're given that d of n will be the number of digits in term n. So to find d of 1, we can just add 2 plus 2 plus 3 plus 4. That will give us 11, and similar thing for d of 2, which will give us 16. This will give us 21, and this will give us 26. And then if we sum all this up, our expression will be equal to 74. Now to generate a formula for d of n in terms of n, well, we can just add 2n, n plus 1, n plus 2, and n plus 3, which represents the number of sixes, fives, sixes, and fives respectively. So that will give us 2n plus n plus 1 plus n plus 2 plus n plus 3, which will leave us with the expression 5n plus 6. For part C, we're given that s of n will be the sum of the digits in term n. So we just solve for s1, s2, s3, and s4. So for s1, notice that it will be, well, first we can multiply 2 by 6 to get the sum of digits for this part being 12. This part being 10, that will be 2 times 5. This will be 3 times 6, which will be 18. And this will be 4 times 5, which will be 20, leaving us being S1 with equal to 60. Same thing for S of 2, you'll get that this will be equal to 88. S of 3 being equal to 116. And S4 being equal to 144. Therefore, our expression in the question will be equal to 144 minus 116 plus 88 minus 60, which will be 56. Finding the formula for s of n in terms of n is not that hard, because notice that the sum of digits of the first part will be 2n times 6. Since we have 2n sixes, that will be 12n. For the second part, there will be 5 times n plus 1, or can be expanded as 5n plus 5. And for the third part, that will be 6n plus 12. We're just multiplying 6 with n plus 2. And then for the final part, that will be 5n plus 15. We're multiplying 5 with n plus 3, leaving us with an answer of 28n plus 32. The statement in part D is equivalent to solving the equation 2n plus n plus 2 is equal to n plus 1 plus n plus 3, where the left hand side resembles the number sixes in A of n, and the right hand side resembles the number fives in the same term A of n. I'll just quickly speed this up. Solving this will give you that n is equal to 2. So in fact, the second term has an equal number of sixes and fives, which ends this video.